Hey everybody, so in this video I'm going to be talking about the concept of formal charge in chemistry and some of the general rules of it. And then we're going to go over a sample problem. So to begin with, all right, I'd like to start off with the general rules of it. So let's say we have a molecule like H2O, it's neutral. So the sum of all formal charges of each participating atom, all right, that sum has to equal to 0 because it's neutral. If we have an ion like nitrate, okay, it has a charge of -1. So the sum of all formal charges within this ion have to equal -1. Okay, and then here we have I have written down the formula of finding the formal charge. So when you're looking at an atom inside a structure, the formal charge of that atom would be the valence electrons of it, okay, the valence electron of the amount of valence electrons of that element. So you look at the periodic table, what group it's in, okay, and then minus the number of non-bonded valence electrons. When you're looking at the structure, you count the numbers of electrons that are not bonded, and then minus the number of bonded valence electrons, okay, and then divide that number by 2. And that entire thing would equal to your formal charge. Okay, and another rule that I would like to mention is that if you have a symmetric Lewis structure, okay, so if you have something symmetric like oxygen, I'm just going to make up something where this may not make sense. But if you have something like this, okay, this is symmetric. See, we have the same configuration for Cl on this side as it is on this side, and so therefore they're both going to have the same number, or they're going to have the same formal charge. So you don't have to waste time and find the formal charge for this. Confusion. So I have this problem here prepared. So this basically has so many rules involved. It's a very comprehensive example. So let's just start and find the formal charge of each individual participating atom. So first we could recognize that it's symmetric, like I said before. See, this side, okay, the oxygen is the same as that side. So we're just going to find the formal charge of one of them. And automatically we know that the other one is going to have the same formal charge. So to begin with, let's just use that formula that I mentioned. So right here we have, let's just start with the oxygen on this side. So this oxygen, if you look at the periodic table, the number of valence electrons is equal to 6. So you have 6 minus the number of non-bonded electrons. See, these are bonded right here. No, these are non-bonded, and you have bonded right here. Okay, remember this single bond right here. This single means you have 2 valence electrons that are shared between the oxygen and the carbon. If you have a double bond, like the one right here, you have 4 valence electrons that are shared between oxygen and carbon. So, okay, so we have 6 minus the number of non-bonded, and that is 6, minus the number of bonded, divide by 2. And the number of bonded would be, okay, so we had 2 here. Okay, so that's 2. Divide by 2. So that's 0 minus 1, which is equal to -1. All right, so that's the formal charge for oxygen, for this oxygen, -1. And like I said, since it's symmetric, this one is going to have the same formal charge. Okay, so you have 2 more to go, the formal charge for carbon and the formal charge for oxygen. Note how I did not put the formal charge for this oxygen as -1 because it does not have the same configuration as this oxygen or this oxygen. Okay, so now let's find the one for the carbon. The carbon, okay, number of valence electrons for carbon is 4 minus the number of non-bonded. Okay, they're all bonded. We don't have any dots like this or like that. So that would be 0 minus number of bonded, divide by 2. Number of bonded, we have 2, 4, 6, 8, divide by 2, that's 4. So then that would leave us with 0. So the formal charge for carbon here is 0. All right, wait, okay, maybe just do that. Now, finally, the formal charge for this oxygen. So we have number of valence electrons for oxygen is 6 minus number of non-bonded, 1, 2, 3, 4, minus the number of bonded, divided by 2. Okay, number of bonded, we have a 2 here and a 4. So that's 2 plus 2, 4, divided by 2. So now we have 6 minus 4 minus 2, and that's just 0. So the formal charge for this oxygen is 0. And so, as I said, there's a rule before that states that the sum of all formal charges within that molecule or ion has to be equal to the charge of that ion. So here we have a charge of -2, so the sum of all these formal charges within have to equal to -2. And that's a way to check your answer. So we have -1 and -1, 0 and 0. The sum of those two would be -1, -1, -2, and that's it.